Hello, this is Mrs. Ringrose, and we are back at it again to learn about inequalities. So here we go. An inequality basically is a comparison that shows sides are not equal. All right, so think about the word equal in that word. And then think about how it says in the beginning, and that means it's not equal. So the ones that you might know well, or maybe not at all, I don't know, are up on your piece of paper. And the first one we read as is less than. And that word is very important because without that word, less than could mean subtraction. But if you put the word is in there so that it shows comparison, then you know that it's less than or it's smaller than the other side. The next symbol means is greater than. Again, you need that word is there. You could also read that as is more than, is bigger than. Any of those will work. The next two are a little bit different because they have an extra line underneath. So this first one means is less than or equal to. And you might not have seen these two yet because in middle school you were always dealing with numbers and you would know that 6 is always less than 9, right? So that makes sense. So you would just use is less than. Well, now that you're in high school and you're doing algebra, we might use, variables to represent a number. So you might be talking about y could be less than or equal to 10 because you don't know what y is. So in that case, y could be 10 because it could be equal, or it could be 5 because it could be less than. And either way, it's a solution to that inequality. So remember, we're always looking for things that makes it true, and any of those numbers would be a solution. The next one is greater than or equal to. All right, and the same thing with the variable. If you are trying to find all the solutions to x is greater than or equal to 1, the solutions would be the number 1 because it could be equal, or it could be 3 or 8, anything that's going to be bigger than 1. So 1 and all the numbers bigger. All right, so then we have a good way to represent all the answers to our inequality is with a graph. And we're going to graph on number lines because we just see one variable. So in words, if you're looking at the inequality x is less than 2, in words, you could think to yourself all the numbers, and this will help you with graphing. If you think of the phrase all the numbers in place of x, less than 2. All right, so you see that number 2 that we're comparing all the numbers to, and you're thinking of all the numbers less than it. So when you go to graph, you don't have to be crazy with a bunch of numbers. I like to see 0 if it seems reasonable, and then get the number that you're comparing it to, and maybe a couple numbers on both sides. And what you're going to do is you're going to find the number, which is 2, and this one you're actually going to put an open circle or an open dot on 2. And I'm going to talk about open dot and closed dot more in a little bit. And you want to shade for me all the numbers that are smaller than 2. So if you look at your number line, which way do the smaller numbers go? They go to the left. So you're going to actually shade your number line as far as you want to go and put a little arrow because it still goes even farther back than that. All right. Next question. X is greater than negative 2. So again, you can think of x as all the numbers bigger than negative 2. So when we go over to graph, I'm going to throw up a negative 3, a negative 2, negative 1, and I'm going to use an open circle to show that we're starting at negative 2. And then I have to think to myself, which way should I shade to show all the numbers that are bigger? Well, all the bigger numbers are going to be to the right, because that's where the positive numbers go, and then they just keep getting bigger. So you have to have a good grasp of your number line. All right, next one. X is less than or equal to 1. So again, we're going to think of all the numbers 1 and smaller. So again, this is a less than or equal to situation, so I want to include 1. So when I come over here to do my number line and I graph all the solutions, this one's going to get a closed circle. So now I want to talk about the difference. The open circle is for less than or just greater than, when you're not including the number that you're comparing it to. And then you're going to use a closed circle for is less than or is less than or equal to, and is greater than or equal to, because you're actually going to include those numbers. So I have a closed circle on 1, and then again I want to shade all the numbers that are smaller, so I'm going to shade backwards. All right, and that would be the correct answer for graphing that inequality. All right, and then finally, x is greater than or equal to 0. So you're going to say to yourself, all the numbers 0 and bigger. And again, we're going to do our number line, and I'm going to be really lazy and just put a 0. And I'm going to do a closed circle, or closed dot, to include 0. And I'm going to shade to the right to show all the numbers that are bigger. Alright, so that's basically how you show solutions of inequalities in a nutshell. Then I have a couple more that I can practice with you. Or, hang on. Okay, so I'm actually just going to get you started with one, and then you can pause this and finish them and get them checked if you want, or you can come back to it later. So the first one, I'm going to look at it, and it's all the numbers that are bigger than 1. So I know because there's no equal sign with it, it's going to be an open dot on 1. And then I want to make sure that I'm shading in the numbers that are bigger. So I'm going to shade this way, because those are where the numbers are bigger. And if you're ever unsure, like that you're shading the right way, you can always pick a number and check to see if it's a solution. So what's a number that I shaded in? I don't know, let's pick 5. So we're going to substitute that into my inequality, just like you would an equation, and you ask yourself, is 5 greater than 1? And if the answer is yes, then you know that you shaded the right way. So that's always something you can do if you feel like you need to check. All right, so inequalities, again, it's a comparison that shows values that are not equal. And we just finished doing the shadings, but we didn't talk about any of the solving skills. So I'm just going to briefly go through a couple of them. For the most part, you can actually solve inequalities the same way you would solve an equation. So if you look at the first one, you want to get rid of that 4 to make sure that x is by itself. So I'm going to minus 4 from both sides, just like I would an equation. These cancel out, and I get x is less than 6. Right, and then you could go ahead and graph that, just like we did in the previous section. The next example, I'm going to have to add 8 to both sides to cancel this out. And this cancels, and I get left with x is greater than 8. And then that would also get graphed, just like we practiced. So open circle on 8, shade to the right. All right, if you need to pause me at this point, go ahead. I'm going to change to the next slide. And for dividing and multiplying, however, there is a trick. So make sure you're paying attention right now. So that one's tricky. All right, the first one, notice how the 4 is positive. So if I go ahead and divide both sides by 4 to get my x by itself, I get x is less than or equal to -3. So that's fine. I'm going to come up here, do my closed circle on -3. And I want to shade all the numbers that are smaller than -3. So I'm going to shade to the left to show all the numbers that are smaller. And that one's fine. And I'm going to go ahead and test it just to make sure. So I shaded in a -6. So let's see if that works, because negatives are really tricky. Is 4 times -6 less than or equal to -12? It's -24. And because it's a bigger negative, it actually is smaller than -12, so that works. So that looks like I shaded the right way. All right, for this one with the negative, whenever you divide or multiply both sides by a negative, you flip the inequality symbol. So let me show you what that means. So you're going to come over here and you're going to notice that it's a -5 on the variable. So I need to divide both sides by -5, and then this cancels, and you bring down your x, and you bring down your -4, but in between, instead of writing is greater than, you need to reverse the direction of the symbol, and now it's actually is less than or equal to. So this gets flipped. So then when you come over to graph it, you're comparing it to the same number that you would normally think, but instead of graphing the greater numbers, I want to graph the smaller numbers. And let's go ahead and test it, and we're going to test it in the original inequality to make sure I did this right. So think to yourself, what's one of the numbers that I shaded? Oh, -10 is in my solution. So if I were to test -5 times -10, is that greater than or equal to 20? A negative times a negative brings me to +50, and yes, that is bigger than 20, so that's correct. If you're interested in why this has to be done this way, I can definitely show you like a proof or an extended explanation on why this happens. But if you're just someone that likes to follow the rule and you don't really care why this happens, then you should be good to go. On the back, I left the rules for you just in case. So again, you can multiply in this case to get the 1/2 away, and you don't have to do anything crazy. You're allowed to divide the same number if it's positive. The third example, if you're dividing or multiplying by -1, you have to flip it. So notice that these are flipped. And same thing for dividing by -2, you have to flip it. So I hope this is helpful with solving inequalities and graphing their solutions. And again, you can do two-step inequalities just like you would do two-step equations. So let me know if you need any help, and have a great day.